Welcome to Rational Numbers, Converting Fractions to Decimals, Part 2. I'm going to switch to present mode. While I'm doing that, you can get your note packet ready. Here we go. The learning target is I can convert fractions to terminating or repeating decimals. And today we're actually going to go from decimals to fractions. So we're going to go the other way. Let's get a quick definition in here first, just so you have it in your notes. Terminating decimal is a decimal that ends. It stops. Okay, so I have some examples of terminating decimals here in the next section for how do I write a terminating decimal as a fraction. Okay, I have 3 steps that I want you to follow, and they are written in the side column of your notes. You've got to say that decimal. You've got to be able to say its place value, because when you say it, you're going to hear how to write it as a fraction. So that's step 2, write it as a fraction. And then, of course, as always, you look to see if you can simplify it. So first example is 2 places after the decimal. That's to the hundredths place. So I would say that as 25 hundredths. I can hear the fraction as I say it, 25 hundredths or 25 over 100. And now look for simplification. Do the numerator and denominator have a factor in common that you can divide out? You bet they do. It's like money. 25 is a quarter, and 4 quarters make $1. So we're going to divide the numerator and the denominator by 25. When we do that, our fraction then simplifies to 1/4. So the decimal 25 hundredths is equal to 1/4. Let's do another. The second example has a whole in front of our decimal. So we read that as 1 4/10. The 1 is the whole part. It has nothing to do with the fraction. 4/10 is what we're focusing on. So that's 4 over 10. So we have 1 4/10. Our fraction is actually a mixed number because of that whole part. Now when we look to simplify, we're just looking at the fraction. So 4 over 10. Do the numerator and denominator have a factor in common? Yes, they're both even, so we can divide them each by 2, and you'll see that in my work. 4/10 becomes 2/5, so our final answer is 1 2/5. 1 4/10 is equal to the mixed number of 1 2/5. The last example is a negative decimal, because we have that other side of the number line that we are exploring, and we read that as negative 35 hundredths. You need that word negative written out. Negative 35 over 100. Now look at the numerator and denominator. Can they be simplified? Do they have a factor in common? 1 ends in 5, 1 ends in 0. And when that happens, that means they're both divisible by 5. So I'm going to divide my numerator by 5 and my denominator by 5. And my simplified fraction is negative 7/25. So negative 35 hundredths is equal to negative 7/25. The final thing we're going to define today is a repeating decimal. A repeating decimal is a decimal with no end. It doesn't stop. And to show that it doesn't stop, remember we use that bar notation just over the digits that repeat. So I have 2 examples here. 2/3, when you use NITO to get the decimal, it becomes 6/10 repeating, and you put that bar over the 6. There's my bar notation. The other example I have is 5/12. When you do NITO to get the decimal, it becomes 416 thousandths. Only the 6 repeats, so you put only the bar over the 6.